Welcome to this demonstration of my little reinforcement game. You can of course go to my GitHub in the description below and run the game yourself. But since this requires Pygame, I decided to make this video. First I'm going to show how the game works, then I'm going to show how to solve it with dynamic programming, and last we're going to look at the Monte Carlo solution. Hopefully I will add more solutions as I learn more about reinforcement learning. Okay, here's the game. I have created 3 different sizes. Let's start with a small maze. The goal is to move our little unicorn to the good exit. If you watch the score, it decreases with each step. This will teach the program to finish the game with as few steps as possible. Of course, the program's goal is to maximize the score. And when we get to the good exit, we also get our final score. It was no problem for me to solve the maze. Let's see how we can use dynamic programming to solve the maze. This time we use the medium maze. Dynamic programming don't play the game directly. Instead it just inspects the game states. These states are policy, return and value. Policy is what moves to make to solve the maze. Return is what score we get when we move to a square, and value is how the program ranks each square. We start with a random policy. Let's see it here. Here's a random policy. We don't know how to move to finish the maze, but as we see here, we are learning. But how did we learn? The goal is to maximize the returns. So the program wants to get to the plus 20 up here in the corner as quick as possible, as each step is -1. Let's see how the value states updates. Here. Remember that it said plus 20 up in this corner, upper right. So this 20 spreads to an adjacent square with a -10% penalty. Each square value is based on the return of the next square as well as the future returns. In this case, gamma is 90%, and it represents that the further in the future the reward is, the less we value it. It's better to get $10 today than $10 next year. And now we see how the value also updates. In the training, the value states and policy states are updated in an alternating fashion. And finally, the Monte Carlo. Now we look at the large maze. The large maze is trained 10,000 times. That means that the computer did try to solve the maze 10,000 times. And the program did this with random starts, so we are allowed to start anywhere in the maze. In the beginning, our strategy just to move more or less randomly, but as the program gets better and solves the maze a few times, the randomness goes down and the use of the policy grid goes up. We start with a random 50% and policy 50% and end up using only a policy. Let's see how that plays out. Here is the first one, and as we see, it just moves around and don't know how to find the exit. And it will soon fail and the next one can begin. But now it has learned, and it still just moves about 70% using the policy and some random movements, as we can see. But it gets better and better and it learns quite rapidly. And I'm only showing 9 of the 10,000 tries. And here, let's see what happens when we're closing in to 100% following the policy. Looks really good. And finally, we move to the exit without any problem. And also the policy updates quite nice. And that's all, folks. Thanks for watching.